Okay, all right, we're going to look at Unit 2, absolute value. Okay, so on the actual test, you are not going to be asked to graph anything, but you are going to be asked to recognize graphs and decide which graph matches an equation or which equation matches a graph. Okay, so what I want to focus on here is this symbol. Like, where do we find that symbol on our calculator? Okay, so on our calculator, this symbol, okay, where we can type something in the middle there, is next to the number 9. Okay, and by next to, I mean to the right, because the only other thing next to the 9 is an 8, and that would not be the right button. Okay, so next to the 9, it has like a little box thingy like this with little squiggly and some stuff like this. Okay, so that's what you're going to see on that button. So I'll show you. I'm going to put in the fraction for the -3/4, and then I'm going to push this button right here beside the 9, and when you do that, this whole big menu comes up with a whole bunch of stuff, and we're going to do this one that's already highlighted because I've been using that one today. Okay, so you just hit enter, and it gives you those absolute value symbols with the stuff on the inside there that you can type the x plus 3, and then go to the outside and do the plus 5. Okay, so the most important parts of this graph are one that it opens upside down, and then we need to know where this vertex is. So if I count over, this is to the left 3 and up 1, 2, 3, 4, 5, which comes from right here. This is a plus 3, so this is 3 to the left, and this 5 right here is telling us we're going up. Okay, so I'm going to go to 3, 5. These are counting by 4s, -3. 5 is about right there, and it's going to crosses here at 1, 2, almost 3, so 2, maybe about right there, and then it crosses over here at 1, 2, 3, almost 4. So we'll just pretend that this is our line, and it goes down sort of like that. Okay. All right. Again, you're just going to be matching. Make sure you know how to type that in your calculator. Okay. All right. Number 2, what is the range? So the range are the y values. Okay, so we're looking up and down, like where does our graph start, going up or down, and which direction does it go, and how far does it go? Does it go forever? Does it stop at some point? Okay, so over here I'm just going to double check and make sure these are all y values. If any of these were x's, those would not be range, so I can just cross them off. Okay, so I'm going to type in my equation. Yeah, you can't figure out domain and range of a graph without seeing its picture. Okay, it's not really something fun you want to do, so make sure you just type in your calculator, make sure it matches. Okay, -1/4, absolute value x minus 3 plus 5, hit enter. Okay, this is my graph. Okay, so the range goes up and down. Okay, so if I start down here at the bottom, this means it goes forever and ever and ever, right? So it's going to forever go down, but it's going to stop right up here at the very top of this point right here, this V-shaped graph. So what number is that? Where does that hit the y-axis? Right there, 1, 2, 3, 4, 5. So that's 5, and then it gets smaller, everything below that point. So I want all values, okay, everything smaller than 5. So it could equal 5, but it can't get bigger, it has to get smaller. So not this, because those aren't 5s. Okay, smaller than 5. So is this symbol is greater, because it opens up to the y, which is bigger. This one is smaller or less than. Going down. Alright, what are the solutions to this? So what we want to do first is we want to isolate the absolute value symbol. So that's this thing right here. So if we want to get that by itself, we got to get rid of this -3. So to get rid of a -3, we're going to plus 3 to the other side, and that makes it go away. So we have 2x plus 4 in the absolute value symbol, and -5 plus 3 makes -2. Now, when I see a negative right here, if you have an absolute value on one side equal to a negative, that is not possible. There is absolutely no way that an absolute value can make a negative number, because the whole point of absolute value is whatever's inside this absolute value, these little bars mean we're going to make it positive. So whatever's inside here has to be a positive answer when it comes out of those absolute value signs. So there's no way we could get negative. So if you see that, negative, once the absolute value is by itself, isolated, if you have a negative on the other side, no solutions. Okay, so we're looking for a positive over here every time. Okay, all right, so same thing with number 10. What are the solutions? So here's our absolute value. We're going to get that by itself, so we're going to get rid of this minus 8. So we're going to plus 8 to both sides, and we'll have 3x plus 6 still inside the absolute value equals 6. Okay, positive number, that's good. So what we're going to do now is we're going to split this into the positive and the negative, because everything inside this absolute value bracket, whatever's inside there, doesn't matter what's inside there, but when we take the absolute value of it, it has to be positive. So the stuff in there right now could be positive, or it could be negative. Okay, that stuff on the inside could be positive or it could be negative. So the only thing I changed is I dropped off the absolute value sign, and I changed the 6 from out here. I wrote it once positive and once is negative. And now we're just going to solve this. So we're going to take away 6 from both sides. 6 minus 6 is 0. Divide both sides by 3. X is 0. Same thing over here. Take away 6 from both sides. Negative 6, take away 6 more, makes negative 12. Divide by 3, that makes negative 4. So these are my two answers for x. X could be 0, x could be negative 4. And if we plugged it back in, 3 times 0 plus 6, that makes 6. The absolute value of 6 is 6. If we put in a negative 4, 3 times negative 4 is negative 12, plus 6 makes negative 6. If we take the absolute value of negative 6, we still get positive 6. Okay, so 0 and negative 4. All right, 11, refer to the figure. This is a transformation of our parent function of a square root. Which function is represented on the graph? Okay, so first thing is, I just noticed that this moves 3 spaces to the left from original. The original parent function goes through 0, 0, right? So this is going to shift 3 units to the left. So inside the absolute value, we're going to have a plus 3. Inside the absolute value, plus 3. That's not this. That's 3 up. That says minus. That says minus. So I'm pretty sure it's this one. I'm just going to double check on my calculator so that I know for sure, because it would be awful to guess or to think something's right and then it's not right. Okay, especially when you have a calculator to double check. That looks pretty close. So it hits here and it goes up through like 6 or 7 there. Great. All right, write the range in set notation. Okay, set notation is this thing. So it's going to be y, and we want to know what our values are for the range. Okay, so the range again goes up and down. So if I start down here at the bottom and I come up to the first place where my graph hits is going to be right here. So what y value is that? Right, that's 0. This is y is 0. Y equals 0 right here. And then my graph gets bigger as we go up. Bigger and bigger and bigger forever. Infinity, right? Because it has arrows up there on the top. Okay, so this is our border for the range. So anything bigger than 0. So any y value where y is greater, could it be equal? Yeah, it could be equal because it's a solid line right there. Greater or equal to 0. Okay, I promise you're going to have several domain and range. Promise. Gotta do that. All right, number 12 is still an absolute value, but now it has an inequality. Okay, just a reminder, the only thing that changes on an inequality is if you divide by a negative, you're going to switch the sign, meaning the absolute value sign. Like if it opens greater than, it's going to switch to less than. Okay, you're going to keep the equal to there. That's the only thing that changes. Otherwise, you still solve it exactly the same. Okay, so the first step is to get this absolute value by itself. So it has this minus 4 tagging on with it. So the opposite of minus 4 is plus 4, and that'll make that go away. So we'll have 3x minus 1 is greater or equal to 7. Is that okay? Positive number out here. We can keep going. We're going to split this into two equations. So we'll have 3x minus 1 greater than 7, greater or equal to 7. Or 3x minus 1, we're going to switch the sign. That's the other difference. Switch the sign when we make that negative. Okay? Okay. So the 7 becomes positive and negative, and the signs need to go different ways. Okay, when we switch it. Then we're going to solve just like we would, get x by itself. 7 plus 1 is 8. Divided by 3. So x is greater or equal to 8/3. Do the same thing over here. Plus 1. Negative 6. X is less or equal to negative 2. Okay, so x is bigger than or equal to 8/3, which matches this. Not this. This is less. So this is okay. X is less or equal to negative 2. Okay. All right. Just a real quick side note, you are going to be asked to graph that. Okay. So if I were to put a negative 2 right here and an 8/3 over here, which is like 2 point something, that's fine. Okay. This equal underneath means it's going to be a closed circle at 8/3. We have a line underneath here, so this is going to be closed as well at negative 2. Okay, this is greater, so we want x's to be bigger than 8/3, so we're going to shade bigger to the right. And here, this is less. This looks like an L, L for less. We want numbers that are less than negative 2. So we do that kind of shading. Okay. All right, one more, because I promise you're going to have this. This is one of the free response questions. Okay. Step 1 is to get the absolute value by itself. 5 plus 2 is 7. 7 is good, it's positive, so we can split this. 2x plus 1 is greater or equal to 7, or 2x plus 1 is less and equal to negative 7. Interesting, they were both 7. Okay, so this is the key right here. The first one is exactly the same, the second one switches the sign and switches to negative. Okay, so now we're going to minus 1, divide by 2, x is greater or equal to a positive 3. Same thing over here, minus 1, divide by 2. Okay, I'm not dividing by a negative, so I just leave it alone. Okay, so my answer, x is bigger or equal to 3, or smaller or equal to negative 4. Okay, and again, my graph would look like this. Both of them would be closed circles still, going opposite directions. Okay. All right, so that's the end of part 2, or unit 2, absolute value. This one, I think you could have some good examples to go onto your cheat sheet. Okay, and remember the calculator buttons. Okay. Love you, bye.